So in this unit, we've been focusing primarily on what's called the electrostatic force, which is the force that makes different charges come together and like charges go apart from each other. And you may be wondering to yourself, how does this electrostatic force compare to our old favorite force, gravity? In this problem, we're going to work out which of those two forces, the electrostatic force, which I've called Fe here, and the force of gravity, which I'm calling Fg here, reigns supreme. So let's imagine that we have two positively charged particles here, and each one of these charges has a positive charge of 1 Coulomb. Let's also assume that their masses are the same value. So we know from this unit that because both of these particles have positive charges, the electric force will push them apart from each other. But because both of these particles have non-zero mass, gravity will try and pull them back together. So for this problem, your goal is to figure out what the mass of these two particles has to be such that the gravitational force and the electric force are perfectly balanced out, so that these particles, when released, will not move. They'll just stand at their current positions. Now, in order for you to figure this out, I'm going to have to give you a little bit of extra information. In problem set 4, we learned Newton's law for universal gravitation, that the force of gravity is equal to this constant g times the mass of the two particles divided by the distance between them squared. And it turns out that for charged particles, we have almost an identical law. This equation here, which we call Coulomb's law, says that the electric force between two charged particles is equal to some constant k times the charge of both of those particles divided by the distance between them squared. Now, I didn't include any information about which direction this force is going in here, but you can figure out what the direction of the force is going to be just by comparing the charges of the two particles. If they're both the same, they'll push away from each other, and if they're both different, then they'll pull towards each other. Now, I hope you find it as awesome as I do that these equations for the gravitational force and electrostatic force ended up being almost exactly the same. This seems to indicate that there's something fundamental about physics underlying both of these two equations. And I encourage you to discuss this idea more on the forums. Alright, so now that you know the equations for both of the forces we're concerned about in this problem, you're ready to try and balance them out. Alright, so given these two values of k and g, can you tell me what the mass of these two particles have to be such that the forces balance each other out perfectly? Put your answer here and use scientific notation, so put the decimal part up here and the exponent over here. Good luck!